Also welcome from me to this talk about advanced graph visualizations in Jupyter Notebooks. My name is Benjamin Niedermann. I'm an algorithm engineer at Yworks, a software company dedicated to create graph visualizations for your connected data. And in today's talk, I would like to show you how to create not only beautiful, but also meaningful graph visualizations from connected data. And with meaningful visualizations, I mean visualizations from which you can actually derive new information for your connected data, so that they actually support you in analyzing your data. And I don't want to do this on a theoretical level today, but more on a practical level, showing you how to do this in Jupyter Notebooks. And I would like to present a simple pipeline that you can use to analyze your data. So at the core of this pipeline, you have Jupyter Notebooks, or the environment around Jupyter. So the environment is basically an interactive computing environment for Python, where you can bring in your data and analyze this interactively by executing blocks of Python, and then you get some results for this analysts, and then you can continue doing this in an interactive way. This is very comfortable and became very popular in data analysis. And of course, you also need to somehow bring in the data into Jupyter, into the Jupyter environment. And to that end, for example, you can, of course, use databases like Neo4j. On the other hand, it's often very helpful to also visualize the analysis, also to visualize the data. And of course, there are multiple components that you can use. And we from Yworks also developed a component that you can use to create graph visualizations on this data analysis. And to that end, we took our SDK, the main product of Yworks, which is basically a software development kit for creating graph visualizations automatically, and developed a component for Jupyter Notebooks that you can freely use to visualize your data. And in today's talk, I would like to show you how to actually create such a pipeline and to analyze data. And this I would like to show on a very concrete example, namely a music database that I will shortly explain where it comes from. So this music database is called Discogs. It's a discography which is Wikipedia-like, and it has thousands of users maintaining the database. So it has millions of entries about the releases and about artists and also about labels. And what you can do is you can explore this database entry-wise, so you can also edit this. But of course, it would also be nice to learn something about the relations between, for example, releases, artists, music groups, and the artists, and so on. So the question was, how could we visualize the relations in such a large database? And actually, I need to say, okay, maybe this is not the right question to go, because if you think about visualizing millions of relations and each without aggregations, what you probably get is a really large hairball of relations or of edges and the nodes in a node link diagram. So this will become very difficult. So what you could do is, of course, you could start aggregating the information. But if you are interested in single relations, we need to ask another question, I think. And the question is, what would you like to learn from the visualization? And so in this scenario, I started with my colleagues, and I talked to them and asked them, what would you like to learn from such a database? And they said, okay, one said, okay, I would like to learn about the history of my favorite artists. And another one said, okay, I would like to learn who has collaborated with whom. And another asked, are there any spatial patterns among my favorite artists? And even someone else said, okay, in which genres have my favorite music group released their work? And finally, there was also the question, what are the connections between the genres? So what you can see here is that they typically don't ask about the entire database, but only about a certain snapshot maybe of the database, so they would like to focus on certain data. And these questions I took and tried to answer them using also visualizations. So what I did is I started with favorite music groups and artists, extracted a much smaller snapshot of this data with about 60 artists and 150 music groups and some additional data. And this gives me the example that I would like to present today. And for the structure, this is important to also understand later on the Jupyter Node examples. The structure is as follows. We have here this artist node, and this artist node can be, or the artist can be a member of a music group, and the music group releases in some certain genres, and the genres also have some common styles. And then the artists also are born in some cities. The last information is annotated manually. So this is the structure of the database, which I would like to visualize. And next, I would like to go to Jupyter Notebooks and show you in practice how to create such visualization, as you can see on the right-hand side. So I will focus on basic visualization, but I will also consider temporal visualizations, spatial visualizations, and I also will show how to use graph data science in order to obtain such visualizations. So let's go to Jupyter Notebooks. So if you're familiar with Jupyter Notebooks, you know this view. It's Jupyter Labs. What I use here, what you have is some code blocks that you can actually execute step by step. So you can just execute this code block, and then you can go to the next code block and execute this. You get some results, and then you can continue working on these results. This is a very typical approach in this kind of environment. And yeah, coming from Neo4j databases, you are probably also very familiar with how to set up a database and also to connect to this database. And this is the first step that I need to do. So I just set this database up. And then the next step is that I also need to import our module based on Y files. So the Y files Jupyter graphs for Neo4j module. And from this, I import the Neo4j graph widget. And this is basically the entire setup that you need to start with these kind of visualizations. So let's start with some first visualization. And what I would like to visualize is the connection between artists and music groups and this relation member of. So what I do is I create, I just scroll down a little bit. I create this Neo4j graph widget here, passing the driver, and all what I need to do is formulate a simple Cypher query telling the database, okay, I would like to have all relations between artists and music groups, and I would like to return the artists, the relations, as well as the music groups. And this I pass to our widget, and this widget will then ask the database for the data, and then will visualize this data. You can just execute this, and this is computed live on my computer here. Nothing is transferred outside. Everything stays on my computer. And what you can see here is already a simple visualization of these relations. So of course I can also zoom in and pan, and I can start exploring the data. So here at this point, I already see, okay, there are some artists that are member of many different music groups, for example. Just a short notice to the widget that you can see here. You have different possibilities besides these very basic navigation tools. You can also change the layout depending on the information that you would like to show. It's good to also use different layouts. So for example, you could use a tree layout at this point, and then the layout is recomputed and you get a new layout. For this particular example, a tree layout is probably not the best choice, but for other data, so for example, if you really have a tree structure, then you could use a tree layout instead. So let's go back to the organic layout. And typically you don't want only to lay out the visualization, but you would like also to encode further information in the coloring, so for example, or in the styling of the visualization in total. So you would also like to change, for example, the thickness of the edges depending on the information that you would like to visualize. And this is also pretty easy with this widget. What you can do is you can add some basic configuration that you can see here. Here, this is basically the very same query. The difference is that I also add node configurations and relationship configurations. So for example, for the artist, I say, okay, I would like to have a shape that is a round rectangle. I also tell our visualization which color it should be used. This artist color is defined above in a basic definition block in order to keep the present, keep the example here small. And yeah, for the music group nodes, I do the very same, but here I use the ellipse or a circle shape. And what I also do is that I say, okay, the text or the label of the node should be the name. And this is a property that is associated with the music group node. So we can directly access this here at this point. And for the relationship, we can do similar things here. We can, for example, also define how thick the edge should be. So I can change this to, let's say, 10 in order to see the difference. And now the edges become much thicker. So let's do this backwards. And now we already have a bit nicer visualization where we actually can easily comprehend the differences between artists and music group nodes. So the artists are the rectangles, the music group nodes are the circles. And then we can start exploring this graph easily. So then let's go to the next question, or as you've seen on the slides, there were different questions by my colleagues that they would like to answer. And one question was, how are the genres related to each other? And what I now would like to do is I would like to only consider the genres, and then here I would like to consider the relationship common styles. And for this, I don't want to use an organic layout, but a circular layout. So what I do again is I formulate a Cypher query that says, okay, just give me all relations between genres and then return these genres and also the relations, and then apply a layout which is called circular straight line layout. And the result is then this layout here. One moment, I can make this a bit larger. Yeah. Now you can see this. Here the idea is that the nodes are placed on a circle so that you get a really clear overview of the nodes that are existing. And then what we do is we connect nodes with each other using straight lines. And then we also choose the thickness of the edges with respect to the number of styles that they have in common. That can also be defined very easily. So again, what we do is we just add node configurations and relationship configurations. And this time we define the thickness factor not as a constant number, but depending on the edge using a lambda function. And this time we say, okay, we just use the property styles of this edge. We do also some scaling so that the edges don't become too thick. And this is basically all what we need to do to get this information. So basically, if you do your data analysis, it becomes really easy to also visualize your data as a graph here. So next, I also would like to go to another question, namely which genres are preferred by the colleagues, and also how important are they in this database that we are currently considering. And here, to that end, I would like to consider the subgraph, namely projected on the group and the genre, and then also on this place relationship, but not on the common styles relationship at this point. And the idea is that we do some graph data analysis. Basically, you can do here anything that you would like to. And then we use this result in order to annotate our visualization with further information. Here you can see in the first step what we do is we use graph data science. So maybe you are already familiar with this. So this is a package that you can use to apply typical graph analysis algorithms on your graph. Typically what you do is you project your graph on another graph. In this case, I am only interested in the projections on the group node and the genre nodes and the relation place. And then we apply the algorithms, the actual algorithm here, computing the page rank. And then I put this result in a dictionary, in a lookup, so that I can consider for each node the page rank. And maybe I should also say the page rank is roughly spoken gives you the importance of a node in a network. So, and with this information, we can start annotating our visualizations. And this works quite similar to what you've seen before, namely that we change the node configurations correspondingly. So you don't need to understand the entire code at once. Later on, I will also post a link to this Jupyter Notebook where you can go through afterwards so that you can take your time to look at this. I only want to highlight the most important features so that you already get some ideas how this works. So in this case, what I do is I again have a very simple cipher query that just queries all relations between the genres and the music group nodes. And then what I do is I add the node configurations that I have computed, or I change the node configurations based on the rank values that I've computed in the first step. And this is what you can see here. I have here this getScale method or function that asks for each node the rank. It looks up the rank, and based on this rank, it scales the node. And for the visualization, we will be only interested in scaling the genre nodes. And then what we do is, again, we just change the add node configuration or the node configuration, setting the size of the node, this time not constant, but using the getSize function, which basically also uses the getScale function. And with this, we can already apply a cipher query, and at the end I also say, okay, I would like to use the organic layout. And the result is then the following layout. I zoom out a little bit, and what you can see is that the nodes have different sizes. The genre nodes and the music group nodes have all the same sizes because I didn't show the page ranks for them. And what you also can see here is, for example, that rock and pop is obviously are important genres in this data snapshot. And what you also can see is that they have many music groups that are only related to this genre, but there are also music groups that have that are related to exactly two genres. So, for example, pop and rock. And so you can continue exploring this data snapshot. Next, I would like to go to another visualization where it's about spatial hotspots. So the question is, are there spatial hotspots for the artists that we are considering? And what I would like to do is I would like to consider the cities, so where the artists are born in. I would like to consider the music group nodes and the artists. And based on this, I would like to create a visualization. I will first show the visualization so that you get an idea how it should look like, and then I will explain how I can create such a visualization. So don't be afraid about this source code. You don't need to understand everything in detail during this presentation. I will just highlight the most important parts later on. This is the visualization. It's a world map that maps the cities of the artists. And what you also get is the edges between the artists, how they collaborated to each other. So basically the idea is that I take the collaboration network between the artists, also based on the music groups, and I project them on a quite simple graph whose nodes just consist of the cities where the artists are born in. And then I also relate the edges to this. And what you get here, for example, is that you can see, okay, in this data snapshot, we have a lot of artists in Europe and also in the US. And what you also can see is that behind of these nodes, there's a heat map. And this heat map basically shows the number of releases the artists have published. I can zoom in a little bit, and what you can also recognize here is that, for example, you have here a small cluster. So this is one music group. And if you're a bit familiar with the history of music groups, then you probably can guess, okay, this is ABBA. And what we can see is that ABBA is basically a Swedish band, but there's one artist also born in Norway. So let's go to the source code. So don't be afraid about this cipher query. This is quite simple. Actually, it's just a projection of the collaboration graph on the graph using the cities. What I need to do is I need to transfer some information and creating also some virtual nodes and virtual relationships. But basically, it's just a projection of a graph on another graph. I would like to focus on configuring the visualization, on creating the heat map, and also telling where the location is. And here what we can do is we can say for each node that we would like to define a heat, and this heat is defined by this heat mapping. And the idea is that we take the total number of releases for each element, and then we map this to a relative number, and we return this normalized value, and this heat is taken for this node on the heat map. The very same applies for the coordinates here. The idea is that we map or we tell the visualization where to place the nodes, and for each node we have annotated the world coordinates where the city is actually placed. And this is everything that we need to do to gain or to obtain this map. We just need to configure this node visualization. And then, of course, we can also configure the configuration of the relationships. And at the very end of this cipher query, we also say, okay, we would like to have a map as a layout. So this gives already this kind of visualization, and the cipher query itself, here you are really free in doing what you would like to do on your data. So the next example is even a bit more complicated in the sense how you can interpret this, but it's a quite nice example. Here the idea is that, again, we create another graph representing our information. Here the idea is that an artist is not represented by a single node, but by an entire path. So let's have a look at Paul McCartney here. Paul McCartney was a member of the Beatles, and then the blue path representing Paul McCartney, or is member of the Beatles, the blue path represents in which other music groups he is also member of, so in Linda and Paul McCartney, but also the Wings. And the order is the date of the first release of the music groups. So basically what we get is a path through our graph visualization representing Paul McCartney. And the very same we can do also for other artists, and then we get an entire graph visualization telling us something about the history of the artists. So let's have a look how this visualization looks like. I just scroll through the source code. I will explain this later on. And what you can see here is the resulting visualization. We can compute this also live, so it does not take much time to compute this. So this is basically computed in 1 or 2 seconds, and now we get this visualization. And now let's have a look at this visualization. So let's have a look at Paul McCartney, for example. Here we have Paul McCartney. He has 1,300 releases approximately. And then he is a member of the Quarrymen, and we can follow this path here to the Beatles. The size of the group notes are also related to the number of releases. So this is also an interesting way to express information. So we directly know, okay, the Beatles are obviously very popular. They have a lot of releases, or they are really productive. And now we can follow the path further on. And with this, we can also see with whom Paul McCartney has collaborated. And this gives us a very simple but very powerful way to visualize the history of the artists in this particular data set. Finally, I also would like to show you a little bit of the source code. It's not that difficult, actually. What we do is in the Cypher query, we again create a projection of the graph. So what we need to do is we need to create a path for each artist through this graph visualization, and then we need to somehow combine this. And this becomes a bit more complicated Cypher query, but if you take some time, you get the main ideas. And as I said, I will also post the link of this Jupyter Notebook so that you can have a look at this. And apart from this, we just need to add some styling information, so that, for example, that we define the size of the music group notes, but also the size of the artist group notes, artist notes, and so on. And this gives me already this nice visualization. And so with this, you have seen different examples how to do this. And now I would like to go back to the presentation. Yeah. And with this, I also would like to wrap up the entire talk. So what you should have learned in this talk is how to set up a pipeline that you can use for your data analysis, and to visualize your data using graph visualizations. And you should have seen that it's quite easy then to configure these visualizations. The tools that we offer are all free to use, so that you can directly start with them. And if you're interested in the examples, here's the link that you can use to access this Jupyter Notebook. A colleague of mine will also post this link in the chat, and more examples can be also found on our GitHub page. Yeah, and with this, I would like to thank you for your attention, and I'm happy to answer your questions.